Okay, here we go. So sales is our criterion variable, or our DV. That's where we're going to try to predict what is influencing sales. Our three predictor variables are advertising dollars, the amount of airplay the song gets, and how attractive the band is. So we're going to go ahead and run a hierarchical multiple regression. But let's make sure that the measurements are correct. And these are all scale measurements, so we're good to go. Now, we've already checked this data for anomalies, and it has already been cleaned up. It does not violate any of the assumptions, so we're just going to go ahead and run the regression itself. So the first thing we're going to do is analyze regression, linear. So our DV is, let's put it in the center here. Our DV is the sales. Okay, before we enter any of the predictor variables, we as the researcher have to pick the order in which we're going to put them in to this model. So we do know that the attractiveness of the band was the least significant. So we're going to enter them in what we think is the strongest first. So we think that the money talks. So we're going to put the advertisement in first. Click next. We think the amount of airplay is probably the second one. Next, and then last but not least, the attractiveness of the band. Now we're going to check the statistics box. We want estimates. R squared, change descriptives, partial and parts and semi-parts and collinearity, and the dreaded Durbin Watson. Right, the Z predicted. Z residual, that's going to measure the homoscedasticity of the data. And this will allow us to check the outliers using the dreaded Mahalanobis distance. And there's nothing there, so we should be good to go. Let's check it out. All right, here is the output. So first of all, here's your come here, you. There's your means. I'm not going to overly bore you with that. Correlations, they are important, but we're not going to look at those now, and you'll notice that there's significance all over the place. And you see the enter method here? That tells us we're dealing with a hierarchical linear regression, multiple regression. Okay, we entered them one at a time. And here's our model summary box. This has got the important stuff on there. I used to know this stuff. All right, here we go. So the model summary. The first model where we just had the advertising amount, you'll notice the R squared is 0.335, which literally means that about a third of the percent of the variance in the sales can be attributed by how much they spend on advertising. Okay? And then the second model is where we added the airplay into the regression model along with the advertising, and look how big that R squared got. It got to 0.629. It almost doubled. And in the last model, we added in the attractiveness of the band. So that had all three of them. It had advertising dollars, airplay, and attractiveness of the band. But you'll notice that the R squared, it did not change that much from the second one. So we're going to jump over here to the R squared change column. So just with the advertising dollars, that should be the same as the first R squared, and it is. But look how much it changed when we added in the airplay. So that's just the amount of change strictly caused by airplay. So that's about 30% of the variance in sales can be explained specifically by the airplay. And the attractiveness of the band, again, it's only about 3.5%. It's not very critical. All right, now we're going to jump over to the significance column, and they all three of them are significant. But it looks like the major players here are the advertising dollars and the amount of airplay that the songs get. Last thing from this box is we're going to look at the Durbin Watson. Let me move this over a little bit. The Durbin Watson statistics, that should be between 1.5 and 2.5, and it is. So that means we did not violate the assumption of autocorrelation. Okay. So continuing on. All right, now let's take a quick look at the Anova results, which we kind of already know, right? The first model is significant, the second model is significant, the third model is significant, which we kind of knew from beforehand from our model summary table. So all three models are significant. Okay, and here's the gutsy of your study. We're going to go to the coefficients. We're actually going to look at the beta weights. Let's get this computer to work right. So beta weights. I'm just going to go down to the third model. So there's the advertising. The beta weight is 0.51. Playtime is 0.512. You'll notice they're almost identical to each other. And attractiveness of the band is only 0.192. So according to this model, the number of times the songs are played on the radio just barely edges out the amount of money spent on advertising when it comes to predicting record sales. All right, so remember the attractiveness of the band, the R-squared change was only about 3%. So we're going to look at model number 2 again. That's the one without the attractiveness of the band. Now look at these beta weights. And again, it looks like the radio play, the airplay, is a little bit higher when it comes to predicting the record sales than the advertising budget. So what we would do is we would suggest to the CEO that they focus their efforts on trying to get the songs played more frequently on the radio, because that's going to be a better indicator of what their sales are going to be. So the difference between Model 2 and Model 3, we would suggest to the CEO that they simply drop the attractiveness of the band because it has so little influence on record sales. All right, sticking with Model 2 only, we're going to go down and look at the partial correlations. So you look at these numbers. If you square those numbers, that tells you what percent of the variance in your DV or your record sales can be explained for each variable when the other variable has been controlled. So just off the top of my head is when you look at the advertising budget, that can represent about 40% of the record sales when you control for the airplay, and then vice versa, when you control for the advertising budget, the airplay can explain about 42% of your DV or your record sales. But again, that's when you control for the other variable. Now, when you look at the part in SPSS, that actually means semi-partial in regular language. That is strictly the advertising budget. That's the unique contribution of the advertising budget by itself. The other variables have been removed. And the same thing, you got to square it. So if you square this, it comes out to be about 25%, and that's strictly from the advertising budget. This comes out to about 28%, and that's strictly from the radio play, the airplay, with the other variables removed from the model. So that's what those mean. All right, the last thing we're going to check here is our collinearity statistics. All right, so, and we don't have a problem here. So if this tolerance number, if this number is less than 0.1, you violate collinearity. Vice versa, if the VIF is greater than 10, you have violated the collinearity assumption, okay? So, but we did not. And just a little side note, tolerance and VIFs, they're inversely proportional. In other words, if you took whatever this tolerance number was and you divided that into 1, that should give you the VIFs, which it does. So, but again, we did not violate anything here. So with the Mahalanobis, okay, here is the maximum Mahalanobis number, 18.6. So we're going to go ahead and open up our Mahalanobis calculation sheet. Let me pull that up for a second here. All right, so there's the cutoff we're using. Our sample size is 200. We have 3 predictors. So there's our maximum Mahalanobis distance. If we have anything greater than that, that individual piece of data would be considered an outlier. But back to our data printout, our maximum was only 18.6. So we have no outliers. Almost done, you guys. Last thing we're going to check is the homoscedasticity. All right, there's our scatter plot. It's hard to tell. So we're going to double click. And we're going to add the lowest line. Remember, the lowest line will tell us if it has violated the assumption of heteroscedasticity or homoscedasticity. And that line should be relatively straight. And it looks pretty straight to me. It's not perfect. Let's pull it up again. But it is straight enough. So I would say we did not violate the assumption of homoscedasticity. So I think we're done. So in a nutshell, your report, you would basically tell your CEO that don't worry about how the band looks. You should probably focus on airplay first and advertising dollar second. Those are the best two predictors for the DV, or the criterion variable, of record sales. So I hope you enjoyed it. MGZ and Copilot signing off. Good day.